All right, it's time for Lab 11. This one is on bitwise operations and the bitwise operators that create them. So yeah, here's all the files that you're going to get. It's really just like a bitwise operations library that we're going to make. So here's like, there's a header file, there's a CPP file. You're going to go through every one of the functions in the header file and implement them. So if I can spell the name of the file right, the header file at least, it's got these three things. So the first one is bit set. See if a certain bit number of an original number, like here's your original number, see if bit number 3 was set of that. It'll give back true if it was, false if it wasn't. Count bits counts the number of bits that are set, and by set I mean is a 1. Unset is 0. So count how many bits in an int are set, give back how many, and then set bit, force a number to have a bit set. Even if it was already, just keep it that way. But if it wasn't, make sure it's set. So yeah, given a number by reference this time and a bit position, then set that bit position to a 1. All right, so set the bit, please. And you'll go in the implementation file, you will implement it. All right, so not too horrible, I think. Remember that the bit number that's being given to you, that's like I here, remember that the numbering is important. It starts at the very right. The rightmost least significant bit is bit number 0. And in ints, you have 32 bits. And so it goes 0 and then 1, like bit 1 is the second to rightmost bit. 0, 1, all the way up to bit number 31. That's as big as you can have for ints, at least. Okay? So yeah, is bit set tests if a certain bit number is set. And yeah, it's going to be a certain bitwise operator that gets you there that you'll check for, right? And then you'll compare, like, was the answer 0? Was the answer not 0? Is that coming back to you? So there's that one. And then count bits counts how many bits were set in your int. For example, the number 7 in binary is this, right? 3 1s at the end, but 0s everywhere else. So count bits on the number 7 should give back 3. There are 3 1s in the binary representation of this number as an integer. Okay? So that's it. That's the secret. And yeah, set bit, just take something by reference, and so you're setting the bit number of that. Okay? So notice how there's a trick, right? There's a way to do this quickly. You can use, in count bits, you can use is bit set. Yes? That would make your life so much easier. Yes? So keep that in mind as you're implementing things, and then set bit, just make sure something's set. So there's that. Get those to work. I've given you a make file, and here is a file that like has some tests in it. So the make file is going to, like, you just say make, or make test bit ops. It's going to make this test bit ops program that includes your library. And makes it all work. All right, tests and sees if it's correct. So test is bit set, test count bit, test set bit. So I got a bunch of tests. They're looking like this, right? Making sure that all of your functions are doing the right thing. So yeah, I think that's what I wanted to say. Is-bit set only works on, I should say, is-bit set takes an unsigned int, so it's meant to not be negative, but by passing along -1, it's going to be converted into an unsigned int, and -1 in binary, remember, that's just all 1s. So that's just making sure that that's working. Like, all 32 bits are set in -1. That's the number with all the 1s set. So I could have written the, like, whatever 4 billion value that it was supposed to be, but it's easier that way. So it's going to be converted to the largest unsigned int when I say -1 there in the tests. So yeah, making sure that all those are working. And yeah, after you got all those passing, your last job is to write some more tests. So yeah, once you've got all mine working, it's the make file will do it. And then I would like you to make 2 more tests, come up with some weird, wild scenarios, maybe some combinations of things would be good. But twice more, I want to see assert true, please. So 2 more extra calls to it, 2 more times it's saying passed, and that's your lab. All right? So yeah, just 2 more tests after you get mine to pass, and you're implementing the BitOps library. So you can't mess with the header file. You're just going to turn the implementation file in. You can't change the header file at all. And then you're writing your own tests. So you're going to turn in that file as well. And I think that is all that I wanted to say. That will be your Lab 11. Keep track of that due date, and good luck.